Today we'll talk about solving quadratic equations by finding square roots. It sounds a little intimidating, I know, but a quadratic equation is only something that has a variable, so like x squared, and then it could have other numbers after it. So that's what makes it a quadratic. You need that squared in there. And you're going to solve these quadratics by finding square roots. So an example of a quadratic equation, basically the formula for it is ax squared plus bx plus c equals 0. So you could have something like 2x squared plus 5x plus 7 equals 0, and that would be a quadratic equation. You could also have 2x squared plus 4x equals 0. In that case, your c was a 0 value, so it just canceled out. You could also have 2x squared plus 10 equals 0. So in that case, your b value canceled out. And another example you could have would be like 2x squared equals 0. So in that case, your b and your c canceled out, and you just have that. So as long as it has that squared on the variable, it makes it a quadratic equation. When you graph these kinds of equations, they make, and I call them a smiley face, but it's parabola. So, and I'll go into why it goes up or goes down. So they make either an upside one or a downside one, and these are called parabolas. And we're going to be working with them a lot. Okay, so to find the solutions to the parabolas, they sometimes call them roots as well. And what that is it's just where the graph hits the y-axis. I'm sorry, the x-axis. Hits x-axis. So a lot of times it's going to hit it twice, because if it's coming down and it hits once here and then it goes back up, it's going to hit it again. Sometimes it doesn't. Sometimes it only hits it once. And then there's times when it doesn't hit it at all. But for the purposes for tonight, all we're doing is solving these equations. We're not looking at graphs or anything like that. Okay, so the first example is x squared equals 4. And you go, well, I know if it's x equals 4 what the answer would be, but how do I solve for this? Well, let's go back to solving equations, just regular ones. When you solve equations, you're really undoing that equation. So this is being squared. The opposite of squaring something is a square root. So I'm going to do the opposite, and I'm going to do the square root of this, and whatever I do to one side, I do to the other. The square root of x squared, you're saying what number times itself gives me x squared? Well, x times x gives you x squared, right? So that means the square root of x squared is x. Now we have two answers for the square root of 4, right? We have 2 and negative 2. So those are your solutions right there. The only, we're going to get into some different situations later, but just know, oh, it's going to hit at 2 on the x-axis and negative 2 if I were to graph it. Let's look at this next one. So we do the same steps, do the square root and the square root. So we know x equals, and we go, wait, 12 is not a perfect square root. So we go over here and do our factor tree, and we break it down into square root of 4 and square root of 3, because 4 times 3 is 12. This is a perfect square, so I get a 2. But I don't get anything here because it's not a perfect square, so I have 2 square root 3. So 2 square root 3. And remember, I could have a positive 2 square root 3 or a negative 2 square root 3. So those are my two answers there. Okay, let's look at the next one. So this one looks a little bit different. So your goal here is, you remember, get everything on the other side and solve for x. So that means I'm just going to add 48, add 48. So I get 3x squared equals 48. Now, just pretend this is an x right now. So I'm going to divide by 3, not even worry that it's an x squared. And I get x squared equals 16. Now I have that basic equation, so I do square root, square root. So I get x equals 4 and negative 4. So if we were to graph that quadratic equation up there, we would see that parabola hitting at 4 and negative 4. Okay, the cool thing is you can apply this to science. So it applies to it applies to falling objects, and the formula for that is always going to be this. So you have h, the height, the ending height or whatever height you want to know, is going to equal negative 16 with your time squared plus your initial height. So let's pretend we're dropping an egg from 32 feet. So my starting height, my initial height is 32. So I'm going to put that plus 32 on the end of the equation. And it says, when will it hit the ground? So we don't know our time. So we go negative 16 t squared, because we know we don't know that. If it's going to hit the ground, the height we want to know is 0, because that's ground level. Now we just solve. So we go negative 32 or subtract 32. And I get negative 16 t squared equals negative 32. And then I divide by negative 16. And that is going to give me t squared equals, is it 2? Yes. Then I do square root, and I get t equals, and for this one I'm going to get a decimal, because I do want to know the time, so I'm not just going to leave it like this. So it's going to be 1.4, and you go, wait, it's going to be negative 1.4 as well. But you can't have negative 1.4 in time, so it's just going to be a positive 1.4 seconds. So after 1.4 seconds, it's going to hit the ground. Okay, that's it for tonight. Have a good night.